experiments of physics, and the first one will be, you can take this. Yeah. So I will be, I had to be very happy intro, but it didn't work, but nevertheless. So the first experiment will be, I will ask my colleague to take a balloon and start rubbing it. Rubbing it to sweeter, while I will take this plastic strip and will try to rub it with my head very, very hardly. Hope it will work for this time. Okay. And let's try it. Okay. And what you will see is that this strip almost. One more time. Very hard. Oh, almost. Okay, didn't work as epic first time. But what have you seen a few moments ago? Why is this strip started floating magically? That's because, first of all, I should start with that all of what we consist is created of protons and electrons. There are also neutrons, but let's forget about them. So you have protons and you have electrons, like they're very, very small and we consist of them. Protons are positively charged, they have positive charge, and electrons, they have negative charge. So what happens because of that, when you have two similar charges, they repel each other. That's how electricity just works. And what has happened here, I will try to show it again. Oh, this time to go freaking out. So what happened here? Why have it started floating? When my colleague was rubbing this balloon with a sweeter, you can imagine that like you are cleaning your room with your broom. Your broom takes all the dust from the floor. The similar thing happened here. When I was rubbing this balloon with this sweeter, it was taking all the electrons from this sweeter. So we have the sweeter, has electrons, and when I take this balloon and rub it, it's like a broom, it's taking the electrons from the sweeter. So for instance, you can now see that my hair gets sticky to that. And the similar, so now we have this balloon. So it now has a lot of electrons. So imagine you have a balloon and imagine a lot of electrons here. You can see them, but there are electrons. And similar thing was happening with this, let's call it. When I was rubbing it through my hair is similar to a sweater. So my hair, this tip take all the electrons. Damn it. It took all the electrons from my head. So now this sphere also have a lot of electrons, and this balloon has a lot of electrons. And as I said before, okay, so we'll show you part. It's good. Almost. So what happens, because this one is negative and this one is negative, as I said before, same charges, they are, you can even see we have the strip and now repelling, and here and repelling. So this similar charges, they repel each other, and because of that you have this still floating. And just interesting fact, here on this little strip you have 620 billion electrons. Like if you can imagine, it's 6, 2, 0, 0, 0, 0, 0, 0, 0, 0, 0. This much electrons on this little piece. This much electrons, and you may think like, heck man, these are a lot of electrons. Like, look at that, how much zeros. Like, and this small trip, so much electrons, you may say like, wow, that's a lot. But actually, that's not a lot of electrons, because I will explain to you. If you will turn on your usual bulb, like in the kitchen or your lamp to work, if you will turn on your lamp for 1 second, this is how much you have electrons. And actually here, maybe you see this little black dot. This little black dot, this is how much electrons we have here. So like here we have 600 billion electrons, but when you turn on your lamp, like for instance this lamp, only for 1 second, that's how, because when you like have electricity, like no electrons going through the bulb, so this how much electrons goes through your bulb in only 1 second. Comparing to how much we have here, so like there is a crazy amount of electrons going at your bulb. And the second part of this experiment is that I will take this one, and maybe you tried it at home already. It always stays. It doesn't fall. Maybe you probably try something like that at home. It's pretty simple. So the question, like, what the heck? Why does it fall? Like, why does it break the laws of physics? To explain that, let's return that anything in this wall, including, consists of protons and electrons. And our ball, because it has no electrons over here, it has negative charge. So for now, you have protons, you have this ball reaching to protons, but you also have electrons in this wall which repel your balance. So like you have negative balance, and the protons inside this wall, they like want to get closer, and the electrons, they want to get more far away. And because those two powers, they cancel each other out, so like nothing happens. But after some time, all the electrons, they slide a little bit, in our case, to this side. So like here you have more electrons. So now all the electrons, they are a little bit more far away than protons. Like we have protons, you see, they are a little bit much closer than electrons. And because of that, now the force of protons, which tries to connect it, is greater actually than our negative force, because electrons are like more far away, they are weaker, and because of that, our balloon gets sticky. And that was the and yeah, funny fact, maybe you saw your cat, something like that. It's the very same thing why this balloon stays here. But now let's go here. Let's go to our second interesting experiment. Sorry, technical nuances. Okay. So I have a usual chain. Sorry for the technical thing. So I have a usual chain. And what do you? Okay. And what do you expect me? Like now it stays peacefully. But what do you expect if I will like just left it like here? Like you would probably expect that the same thing as here, like nothing will happen. But actually, if I will pull it a little and more little and more little,
Nie, tylko to było.
all the other chain.
Ja sobie poradzę, spoko.
All the other chain, some wire has fallen out from this place. Why? Why has it fallen? So you have our chain balls. You have our chain balls, and I push, and the gravity pushed this one down. And all this chain all these chain balls, they are very good bodies and they hold each other very strongly, right? That's why it is a chain. So when the gravity acts on like this chain, they automatically like give this force to other chain, and this chain goes to other chain. So like now when I pull this, I will pull all the chain, and on this side. So like when I pull it automatically somewhat pull other chains. But through some time, like in the beginning I had only a little force because there was a little piece of chain. But when it started falling and falling, I don't know, take this one, it started falling, like we had more chains falling down. And because of that, the force was greater. And because of that, if you will look very attentively now, you see that this chain actually jumps a little. It jumps a little because the more chain it's like makes the force. So because of that, it jumps higher. And for now, the end, and so you have greater forces at the ends of it. That's why it jumps. So now I will make some experiment, and unfortunately the last for today. I will take usual two forks, and I will join them and try to not kill myself, currently. I will join them very tightly. Very tightly join the forks, usual thing. And I will take a little toothpick and just pull it through the forks. And so you see, toothpick through the two forks. And what do you expect me if I will like put this on my finger? You would probably expect it would just like fall, because like, well, two forks, I put that, like, it would just like face it. For instance, if I take this one, what do you expect it to do? To fall! Like, that's how gravity falls, acting gravity. But if I will take a little bit smaller, this toothpick, and will left it on my finger, oops, something doesn't work. So when I will left it, it would not fall, but it would just stay on my finger like that. Moreover, I can take, okay, so we have others. I will take this stick and will try it to hold on this second stick. Actually, it also can even start rotating further. Rotate. So in that case, to show you, I will left it on that glass. So it just stays on the glass. But why does it stay on the glass? Why doesn't it fall? Like it looks like it should fall. Why doesn't it fall? So I have two forks connected with this toothbrush to the glass. And let's see at this picture of the athlete. So if that would be me, I would just fall and break my face. But this athlete, you would expect like the gravity to try him to flip over in this side, because like a lot of body, so the gravity pulls him over. But he walks with his hands to actually rotate himself in the opposite direction. So like we have gravity trying to rotate him in that direction, and his arms trying to rotate him in opposite direction. So it balances each other out, and this athlete, it stays. He doesn't fall. The same thing, similar thing, happens here in that case with the spoons and this toothpick. This toothpick, it works like a hand, and the bottom part, this part of the forks, it tries to pull the ball construction to this side, like let's say to left. It wants to pull it to the left. But also, we have the other part, like these two long legs, I don't know how to call it, these two legs, and they try to rotate him in the opposite side. Like here in the athlete, like arms. He tried to rotate him in the two opposite sides. So those two sides tries to flip over in that side and other side, so they just balance each other, like they're in a balance. So this whole construction works, and I can even, I don't know, try to hold it on a toothpick because of how gravity works. And I can actually it even rotates on this little stick. Rotates. And I want to say, the world is physics if you do not know magic. And for now, I thank you for attention and any questions.
So, does anybody have questions or I can start? Okay.
Who are you and how do you know that?
I am a magician. I'm from village of some village. Okay, I am Danyil Dorosh from the Obuchiv city, born at the 16th August of blah blah blah. I'm from faculty of physics, and if you go on physics on our faculty, you will also teach yourself how to understand all that stuff. So go to the physics on the physics faculty.
He's in biology.
Just not the biology, not the physics.
What? We also have magic, I told you.
Any more questions?
Section. Physics, chemics, I don't know. Any more questions? Wow, that's quite interesting.
No questions.
Okay, maybe what was your inspiration for this presentation? Did you maybe, I don't know, are you working on some project, maybe some videos on YouTube or like Houdini?
No,
or
I'm
something?
nobody. I'm not working on anything. I just think about this idea, like presentation, like I thought like, well, physics is boring, like nobody, like all the people I say that I'm studying physics, like the first they said that, oh heck, I didn't like physics in school, like it's so boring, you know, like thank you, yeah, physics is boring, I know. So like I thought like, well, probably the only interesting way to show physics is and I thought that the only interesting way to show physics is experiments, so like that.
Okay, so thank you so much, Danyil.